Outcomes of this lecture, job setting. By the end of this lecture, you will be able to understand the job setting process, differentiate between jaw setting and job setting, perform jaw setting, remove old jaws using Allen key, lock the spindle using M19 code, load new jaws and align them properly. Perform jaw boring. Use a dummy piece for proper alignment, take precise cuts in X and Z directions, create an undercut for better job holding. Perform job setting, tool offset. Take X and Z offsets for each tool. Enter values in the geometry offset page. Understand tool type codes, OD, ID turning, grooving. Understand Fanuc and Siemens control differences in setting. So our next topic is job setting. So for every new job development, we have to do setting for it. So in this job setting, we have two settings. First is jaw setting, and second is job setting. That means firstly, we have to do jaw setting and then job setting. So let's see how to do jaw setting. So in jaw setting, firstly, we have to replace old jaws with new jaws. And after changing jaws, we have to do jaw boring. So let's see one by one. To remove old jaws from chuck, we have to lose its bolts with the help of Allen key. But if you try to remove these bolts directly, spindle will rotate and you will not able to apply full pressure to remove jaws. For that, you have to lock that spindle first. And for that, we have M19 code. So write M19 code by selecting MDI mode and then press cycle start key. So that spindle will lock. We will see this with the help of video as well. But for now, just have a look. So after locking spindle, you will be able to remove jaws and then load new jaws. So firstly, load new jaws. Approximately and lightly tight. The bolts don't tight fully because we are going to adjust these jaws. So after that, take ID tool near your jaws. And by checking distance of these jaws with tool, we get to know that whether we have loaded jaws correctly or not. So let's see these points one by one in detail. So our first point was to lock the spindle for jaw removal. So see how to lock the spindle. Firstly, press MDI, then write M19, and then end of block, and after that insert, and then cycle start. So our spindle is locked. Then we will remove old jaws. Now we have to load new jaws, and before that we have to select that jaws for that choose such jaws which will hold the job properly. As you can see in first picture, our jaws are not properly fitted with job, and in second picture our jaws are probably fitted with the job. So choose this type of jaws. You get this knowledge only with experience. Okay, so as much as you work in this field, you will get this knowledge. So here we have selected new jaws. So to load these jaws on chuck, we have serrations behind jaws. As you can see, these are the serrations. The similar kind of serrations are also there on chuck. So just fit these new jaws approximately on the chuck. As you can see in video, the serrations gets properly fit on the chuck and then lightly tight the jaws. So in this way, load all three jaws so that your chuck will look like this. And after that, you have to take ID tool near these jaws like this. Take small ID tool so that it will go in between these jaws. And then you have to remember this distance. And after that, rotate jaws to check this distance for next jaw. This you have to do for all three jaws. If this distance is not same for all the jaws, then you have to adjust these jaws by taking that jaws forward or backward, and again, check that distance for all the jaws. So you have to do this procedure until this distance becomes same for all the jaws. If this distance becomes same for all the jaws, then you're jaw setting it correct. After that, take that tool to its home position and then fully tight these jaws. This is how you have to do jaw setting. After that, we have to do jaw boring. So this jaw boring is done for a proper and accurate jaw alignment and also to get accurate size. So for these reasons, we do jaw boring. As you can see, this is how jaw boring looks like. You just have to take a light cut in X and Z direction. So let's see how to do this. So first, hold dummy is in between jaws. This dummy piece must be much smaller than our workpiece. After that, rotate spindle. Then you have to touch boring bar to jaws in X direction. After that, open position window. In that position window, you have to press relative. In relative, write X and then press origin key. After that, you have to touch that boring bar to the jaws in Z direction. And after that, write Z in your position window and then press origin, so that our X and Z becomes 0, 0. So this is how our dummy piece looks like. Here, our dummy piece is quite larger, as we're going to have a big size workpiece. So always remember, your dummy piece must be much smaller than your workpiece. So hold this dummy piece in between jaws like this. Okay? After that, rotate spindle with M19 Code, and then take boring bar in between these jaws like this, and then touch this boring bar to the jaws in X-axis lightly. Then press position key, then relative key, then write X. If your control panel having X, then write X. If we are control panel having U, then press U, and then press origin. And similarly for Z, touch that boring bar to the jaws in Z direction lightly, and then press position relative and write Z or W, whatever your control panel have, and then press origin so that your X and Z will become 0, 0 at these points. Okay, so let's see this with the help of video so that you can understand much better. So after touching tool the jaws in X direction, press position, then relative, then write U, as we have U here, and then origin. See, our U becomes 0 at that point. Okay, now touch tool to that jaws in Z direction, and then write W and then origin. So here we have created all 2 points as 0, 0. Now we are going to start jaw boring. So how to cut jaws? So firstly, we have to take the tool away from jaws, then take tool in X direction up to 0. So that's why we have created these X and Z as 0, 0. Then move tool upward as much cut you want to take. Here I'm going to take nearly 0.2 mm cut. So I will take tool upward up to 0.2, and then we have to take cut in Z direction, as we are going to take 0.1 mm cut in Z direction. We have to move tool up to minus 0.1 mm in Z direction, and then we have to take tool down in X direction and again away from the jaws. So here we have taken first cut of jaws. We have to do this procedure twice. Now in second cut, take tool in X-axis up 0.2, as we have already taken this much cut, and now we have to take 0.2 mm cut again. So move tool 0.2 mm upwards more in X-axis, so total 0.4 mm in X-axis, and then we have to take cut in Z direction up to minus 0.2, as we have already taken 0.1 cut in Z direction. And again, we're going to take 0.1 mm cut, so total minus 0.2 mm cut we have to take in Z direction. And after that, we're going to make an undercut here. So as you can see, this is how undercut looks like. This is done to clamp job properly and to avoid any misalignment. So whenever you do jaw boring, you have to make this undercut. Okay, so from Z minus 0.2, we're going to lift tool slightly upwards, and then take downward in X-axis and then away from the jaws. This is how we do jaw boring. So I will do this procedure on control panel so that you can understand much better. So here we have already done U and W as origin, and our boring bar is away from the jaws. So here I'm going to take tool up to 0.2 in X-axis, as I have to take nearly 0.2 mm cut in X direction. So see, I have reached nearly 0.2 mm. Then I'm going to take a cut in Z direction up to minus 0.1. Here I am increasing its speed, but you guys do it slowly and properly. As we are cutting material here, so you have to go slow. See, we have reached up to minus 0.1. Then we have to take tool downwards in X direction below 0, and then take tool away from the jaws. So we have completed our first cut. Now again, we have to take tool up to 0.4 mm in X direction, as we are going to take 0.2 mm and cut again. So see, just do it properly, as I'm using this simulator, so I'm not able to do that much properly, but you guys do it properly. Okay, so we reached nearly 0.4 mm in X direction. Then I have to take tool in Z direction up to -0.2. So I will stop here. Now we are going to make an undercut here. So take tool upward slightly in X-axis, and then downward below 0, and then take tool away from the jaws. So here we have learned how to load jaws and do jaw boring with undercut. Okay, now we're going to see job setting. So what is job setting? So see, taking X and Z offset values for each tool and putting them in the geometry offset page. This is job setting. That means you have to take X and Z offset values for each tool and then put these X and Z values in the geometry offset page. Now let's see how to do this. So first, touch the tool to the job face when spindle is on. After that, press offset key, and in that offset again, press offset. Then you have to press geometry, and in geometry, select tool number. So you have to select that tool number which you recently touched to the job face, and after that select ZID, and then write 0.0 and then press measure. So this is for Z offset. Now let's see for X offset. So touch the same tool to job diameter when spindle is on, and after that select X. And here we have to write the diameter of the job. In Z offset we write Z.0, but in X we have to write the diameter of the job, and after that press measure. Now let's see this with the help of video so that you can understand much better. So firstly, we have to touch the tool to the job face. So this work we have to do with a very proper and accurate manner, as the whole job size depends on this setting. So do it with as much concentration as you can and try to create yourself as an accurate person. So here, let's rotate spindle with speed 800 RPM. The more you do these settings properly, the more accuracy you will get in your job. Sometimes you have to develop only one job at that time. You require accuracy, so it's better to make yourself an accurate person. So after touching the tool to the job face, press offset key, again offset, then geometry, then take cursor on Z and write here 0.0, and then measure. Do it again for your confirmation. Now we have to touch the same tool to that diameter of the job. Here, I'm explaining this setting by taking offset for only one tool, but you have to take offset for all the tools that you're going to use in your program. So after touching tool to the diameter, write X and then give diameter of the job. Here I'm using 80 mm in diameter, so write X 80.0 and then measure. In R, we have to input the nose radius of the insert which we are using, and this is the tool type which you're going to see in some time. So this is how you have to do your job setting. So let's see about tool type. So that last column in the geometry page is for tool type. So as you can see, here are some numbers arranged in a particular order. You have to remember the sequence. This is the insert cutting direction. So if our tool is cutting material in this direction, meaning our insert is having this cutting direction, then we have to give 01 in the tool type column of the geometry page. This 01 is rarely used tool type. Next is like this. This type of cutting direction we will see in ID turning. So remember 02 is for ID turning. Now third, if the insert is having this type of cutting direction, then its tool type is 03. As you can see, this is doing OD turning. That means 03 is mostly used for OD turning. If you want to do OD turning in reverse direction, then use 04 tool type. 05 is for this type of cutting direction. This is the rarest tool type used. As you can see, it is going through ID and cutting like this. 06 is used when we have to make a groove in ID. At that time, 06 tool type is used. 07 when we have to do face groove, and 08 when we have a deep groove on OD. So this is all about tool type. Here I have written a note for you. 03 is mainly used for OD turning, and 02 is mainly used for ID turning. So remember these two tool types. 03 is for OD turning, and 02 is for ID turning. So if you remember these two tool types, then it's more than enough. So here we have seen the whole setting in Fanuc. So let's see this setting in Siemens. Here, jaw setting and jaw boring is the same. The only difference is in giving offset in the geometry page. So first, let's learn the procedure. So first, touch the tool to the job face when spindle is on. After that, press offset. Then in offset, we have to select geometry, and in geometry, select the tool number, which we are using to do the setting of that tool. And after selecting tool number, press measure tool key. And in measure tool key, press measure Z. And in measure Z, we have to put Z.0 and then set length Z. So this is how we do job setting in Z. Now, touch the same tool to the job diameter when spindle is on, and after that we have to press measure X. And here we have to write the diameter of the job. And after writing the diameter of the job, press set length X. So as you can see, there is a little difference in Fanuc and in Siemens. So here we have completed our setting topic.